have the experience that I had. Well, back then in 2015 when I first heard about Ethereum, actually I had heard about Bitcoin probably 2013 and was just mind blown, and I spent a whole summer just reading about Bitcoin, trying to convince myself that it was bullshit because it just made no sense whatsoever. It couldn't possibly be true. And then I didn't really believe that it was true, but I bought some Bitcoin back then because it had skyrocketed in like January, I think of 2014 or 2013 or something like that. And 2 months later, Mt. Gox happened, and it went from my $600 per Bitcoin to $120 per Bitcoin. And I'm 100% convinced that it was exactly the bullshit that I knew it was, right? So I just got out of the space completely. And I went back to teaching. I was teaching English, writing, and stuff like that. So, and then I heard of Ethereum in like late 2015, and I'm like, this is something special. I quit my job like the next month, and I never turned back. And I'm wondering, so back then, I used to go to conferences, and almost every speaker would stand up and say that exact sentence. As soon as I understood what Ethereum was, or blockchain, let's say, and I don't want to get into a L1 war, they quit their job and they threw away their career and they walked into this space that was completely crazy. And I just, does anybody else have that experience here? A fair number of you. Why? So my why are three, and one is privacy, one is speed, and I'll try to explain what that means. And the other is this idea of having solved the prisoner's dilemma. And back then, every person I met was absolutely certain that we had solved the prisoner's dilemma. Which I'm sure all of you are familiar with what that is, I suppose. Yes? Maybe? No?
No.
So it's, I'm going to try my best here, but it's when two entities or two people are in a situation, both of them look at the other entity and they say to themselves, I know I can cheat in this situation, therefore I can calculate out that he can cheat or she can cheat, and therefore my only legitimate response is to cheat. Because if I don't cheat and they cheat, they win. And everyone, I think every human being from the time they're 2 years old understands that dynamic. And I think it's deep, deep, deep inside of every person everywhere they go. We know who has the advantage. And we know that we have to protect ourselves and be careful if someone else has an advantage. But if we can be certain that that other side can't cheat, then we wholeheartedly join in an organization, and it's better for both of us at the same time. So that's the prisoner's dilemma, because we know they can cheat, we know we can cheat, and our only response is cheat. I think that blockchains solve the prisoner's dilemma because they're so transparent, because that's what, I should say it this way. Every person I met back then knew that that was true, and that was what we solved. And that's why they quit their job, because they're going to go work on solving the prisoner's dilemma. So we can build organizations that cannot hide the details of the inside of the organization from us, because we can see into the organization. And that's what that's why it's so important it's decentralized, because I have to be able to join the data flow without anyone, without buying my way in, without paying someone, without relying on someone else to give me the data. And then I say, this is a fair system because I can see into the organization and I know that it's legit. And now I'm willing to join and I jump in. And I think that's exactly what happened with, what was the name of that file sharing thing back in '96?
Napster?
What's it called?
LimeWire?
Napster.
Yeah.
If you think about Napster for a second, it's like every person that comes to this system, they say, I have 7 songs. If I join, I have 10,000 songs. Yes, of course I'm going to join. I have 8,000 songs. If I join, I get 10,000 more songs. So everybody looks at it and they say, this is beneficial to me. And I think that's exactly what these blockchains did. Because we saw that we could build organizations that couldn't cheat, that we could get the best possible outcome among a group of people working together without anyone being able to cheat. And that's why I quit my job, basically. So I'm going to try to talk about these three things: privacy, speed, and then this. This is hard to talk about, but I'll try to talk about that. This is about TrueBlocks, and I tentatively titled this, Why You're Building the Wrong Thing. And what I'm saying is, you're not building a solution to the prisoner's dilemma. Nobody is. I haven't heard this idea in 10 years. And in fact, I think we're building a much, much, much worse system than we already have, which is really bad because of people like that who invade privacy. So we're building a system that literally they can see every expenditure I make. And I'll give you a quick example of that. I write software that scrapes the chain and looks at all the data. And I was online with a friend, and I was showing him his history of activity. And we started looking, and I attached names to addresses. And one of the names was Pornhub or something like that. So we're looking at his history. Every week, every Saturday, like 7 or something. And then I was like, oh, let's look at your GitHub grant activity. And so all this money was coming in GitHub all week, and then he'd spend it on. So I didn't even try to invade his privacy, but it's like this data is so open and so available that we have to figure out how to make it private. Otherwise, we're literally building something that's just ridiculously unprivate. So I'm going to just talk about privacy for a second. So I think it's true that an L1 is kind of in the cloud. It's kind of up there. And we, the little people, we interact with different companies that give us access through. Does everybody know what an RPC is? So we interact with Linea through an RPC, we interact with Optimism through an RPC, and then they interact with the L1 mostly. And we can also have our own access to the L1, but we usually go through a remote provider. So if you look at this, that looks like a circle and it's closing on the L1. And I think that over time, this will completely close to us. We won't be able to get into the system except through companies. And now, we've literally created, inside, great, it's an L1, interesting. It does all these magical things. Outside, it's just an RPC endpoint, it's just access through a server. So it's literally no different than Web 2, except for the fact that I'm spending money on Pornhub. And every human being that's in one of these companies can see that. That's such a bad idea. So this coming privacy invasion, we think we have it bad now, it's going to be much, much worse in the future. So when back in 2015, when we started, you couldn't access this L1 without running your own RPC. It's just not possible because there was no service providers. So every single person who joined just started a node on their computer. And it was a total disaster. It sucked. It was horrible. Even though the chains were super small back then, it took 3 days to synchronize your chain. And then if you shut it off for like a day, and you come back on, now it takes 25 minutes to start your application. No, these people, outside service providers, they're fine. There's no problem with these people being here. In fact, you can't stop them from being there because they're just part of the ecosystem. But my argument 6 years ago, when I got my first Ethereum Foundation grant, was you cannot leave the RPC in the shitty state that it's in, because API providers are just going to completely surround this thing, and you're not going to have any access to this thing. So TrueBlocks works with a local RPC. and this has been from minute one of my project, has been what's wrong with the RPC and why can you not do what you want to do? And what do we want to do? What would you want to do? What I want to do is I want to see everything that I've done on the chain without asking permission, without anybody knowing I'm looking. Because if I go to Infura, there's an IP address transferred right here between me and Infura, and they know every person's IP address, whether they tell us that or not. They absolutely know who you are. They know everything I do. Plus, every time I go to Etherscan, I go to the same address, every single time. So my idea and my basic thing was fix the RPC. Like, what's wrong with it? Why doesn't it work? And build a piece of software that lets you build applications that are, it turns out, way faster, perfectly private, and I think ultimately will be the only way we can ever solve the prisoner's dilemma, because only when I have direct access without any permission do I know that I can trust what I'm seeing. If I have to go through here, these guys could get taken over by China or, you know, these guys or something, I don't know. They can lie to me. This data can't lie to me because it's agreed to by 50,000 computers on the planet. So that's TrueBlocks, that's what I'm trying to build. Is everybody with me here? All right, now, I said speed is really, it's unbelievable how much speed you can get from a local application if you have your own RPC. And there's a very, very simple explanation for that, and I'm going to talk about that for a second. So this is Moore's law. Speed of computers over time basically skyrocketed from 1995 till now. This computer here is 1 billion times or more faster than that computer there back in 1995. But when I use the web, I'm sitting there getting spinners and loading pages, and I have to click on pages to go from one page, next page, next page. That's built in on purpose because this benefit, this 1 billion times increase in the power of the machine, was taken 100% by the server companies because they could put more people on smaller machines. And they gave us nothing, and that's why our web pages take forever to load. Because they're watching everything we do. And this is easily explained like this. This is a web server. Say it's 1,000 times more powerful than my desktop, but they share it with 10,000 people. I share it with me, just myself. So they get 1/10 of the machine, I get one machine, I'm instantly 10 times faster. But I think this is actually much closer. I think this is probably 10 times more powerful, if even any times more powerful than a desktop. So let's just say they're equal. I get 10,000 times faster machine because of just me on one machine. And I hope I can show you that with this application that I built. So that's speed. And then the last thing is this game theory prisoner's dilemma thing, which I'm going to let you guys figure out because it's impossible to explain, basically. Other than to say this, that when you have a truly permissionless data source, so you can think of this L1 or any of the blockchains as a data source, right? And when I can join that data source without any cost other than my own cost that I take on myself to run the software myself, like you, for example, I think only then do you get you get the belief in the transparency that allows you to wholeheartedly join without any reservation these organizations that I wish we could build. But I fear that we're never going to build. So for the rest of the time, I'm going to talk about my project. And this, I believe that the single thing most wrong with the RPC is it doesn't index anything. And I'm going to talk about this piece of software which does this indexing. I'm going to show you a little thing to build applications just with a one-liner. And then I'm going to show you 3 different applications. About the data. And reason why it's trustable is because once a block gets created, it's zero possibility of that block being changed. And everybody knows this as immutability. And it's linked back to the previous block. So the whole entire history of the chain is immutable. And that is also one of the reasons why I quit my job, because I don't think there's ever been a system where, especially a peer-to-peer publicly available data source, that could not be changed after it's laid down. I think people missed something about the fact that immutable data has this aspect to it that I think people missed. And one of the fundamental ideas behind TrueBlocks, and another reason why I think I got grants back then, is because what I call provably true data. So once you have, I'll give you a perfect simple example. So you have this history of blocks all the way from the beginning of time to the end, and you can look at a block from your own RPC so you know that it's not tampered with, and you can count the transactions in that block. You can just say there's 3 here, 4 here, 10 here, 6 here, 5 here. That data is 100% exactly as immutable and predictable and reproducible as the block data is. So I call that provably true derived data. So it's any data that's purely from this immutable data. You can go wild with it. You can say a price history on Uniswap or something. That's a truly derivable fact. And it's indisputably exactly correct. So that's one of the things that I kind of latched onto right at the very beginning. The fundamental idea here was identify provably true derived data. And when you tell someone this is the derived data, you attach to that derived data a list of commands or steps or processes that you went through from the original data to arrive at that data. So you don't just deliver the data, you deliver both the instruction set and the data. And that's in here, that's in this indexing thing. So one of the things we built was this thing with Katra, which is constantly watching the chain, indexing the chain, and publishing not only the data that it derives, but the specification for how to derive that data. So anyone who wants to pick it up can convince themselves that it's true. What Bitcoin did is it incentivized the creation of these blocks. And it did that by giving people coins to pay them to run the software and create the block. My claim is that the data that you can derive, in particular indexing data, is so valuable to people that simply its existence would be incentive enough to have people run the software and create this data themselves. I believe that was true back then. I don't think it's true anymore. To the extent that we can show people speed on a piece of software that is 1,000 times better than a web application, we may be able to incentivize them to run a piece of software that's a little more difficult to run, like a node software, because they get this amazing fast software. And there's an accountant here. Yeah, right? We have 18 decimal place perfect accuracy of every transaction of 350 million accounts every 12 seconds on this chain, and 0 perfect accounting off chain. So to me, that's another insane, you know this, it's insane. It's a piece of shit. Why do we have 300 million perfect accounting over here and 0 over here? So that was another thing that I thought that we could use that fact to incentivize people to actually take the hard choice to run software that actually finds these transactions. And you know that I've been doing that for years. And it all comes down to indexing. So I gave this talk in Berlin about 4 years ago. And I'll just, so we built, the first piece of software we built is called Shifra, which is Persian for cipher, and or sort of, and it has a whole bunch of tools in it. One of which is called Scrape, and what Scrape does, it runs continually, and every new block it extracts all the addresses from that block. And then you can do things like export, give it an address, and it'll show you not only every place where the address appeared, but every type of data that's available on the chain: traces, receipts, logs, smart contract calls, everything. So we also show basically we can build an explorer with the data, because the data is right there, so we easily can build an explorer. But this is what a typical block looks like. It has a minor block at the very beginning, or a minor transaction at the very beginning, and then it just has a list of all these addresses per transaction. And this is literally the index that we built. Like, what I think a lot of people did back then is they extracted not just, what I wanted to do is, because I want to build on a small machine, I want to extract the tiniest little database I can extract, which is basically where are the addresses at. And then later, I can use that to query the chain for the details of a transactional history. What a regular Web 2 brain would do is extract the entire planet Earth from the chain and put it into a database. And what I learned very early is that it explodes, because you send one transaction, you get 350, 500, 5,000 traces. And the real data, the data that you can't find, is in traces. So if you want to do perfect 18 decimal place accounting off-chain, you have to look at traces. And you can't extract them on a small machine because it explodes to 100 terabytes of data, because it's just such a huge explosion of data. And it's hard to share that data in the way that I wanted to share it, because I'm also at this time, IPFS was floating around, and immutable data that can be hashed into an IPFS hash is literally perfect because it's immutable. I write it once, it never changes, and it's just available to anyone who wants. And I publish the list of all the IPFS hashes, so anyone can go and get this thing from a smart contract and download the entire index themselves if they want it, or any portion of the index. I'll try to explain that in a second. So these are all the places where we kind of found addresses. Some of them are much easier than others. So like an address, it's called address, very simple to find. But that is also an address. It has these leading zeros in it. And but the next one at the bottom here, that's not an address. We kind of chose to say that's not an address. It was an engineering choice, because if we just said any 32 byte thing is a valid address, but we just chopped off. If it's less than 10 digits, it's a number. It's kind of a cheat, but. And then we compare ourselves to Etherscan, and we wildly beat Etherscan's API because they don't track traces. But I want to now talk about this here. May I? This is my report, my end report, so I'm going to just go through it. And you guys have fun. This is a blockchain is a time-ordered log of data. So it's by block, and it's not sorted by address. So it just throws down a whole bunch of addresses, whole bunch of addresses, whole bunch of addresses like this. So each of these colors is a different transaction, and the orange ones are all the same address, but you can see they're all interleaved. And this is kind of the problem with the RPC right here, because you cannot ask the RPC for address histories. You can't say, give me everything that happened, because these are interspersed, and this is the only thing the RPC can give you, block by block by block by block. So the first task is to, and these are, could be easily stored on IPFS as a hash, because this is immutable data. And ignore this is it. So what you do is you sort on address, and you get a nice, easily searched database that you can find the history of an address. But as soon as and you can store that on IPFS, but as soon as a new transaction comes in, this hash changes. So you have a problem. You have either immutable data or you have a sorted index of data, and you can't have both. And that was a real problem for us for a long time, because I wanted to store it on IPFS, because I wanted to publish a list of all the hashes of IPFS so anyone could download it. So we came up with this idea to basically stop stuffing things into the chunks. We would just stop after a while. So once this chunk got 2 million records big, that was just an arbitrarily chosen number, we created what we called a chunk, and we wrote that to IPFS. And now what we're creating is, and this is a true sentence even though it's hard to say, it's a time-ordered log of an index of a time-ordered log. That's what we built. That's what TrueBlocks index is. And we did that on purpose. So, and we built that thing into a thing called Scraper. So the Scraper did that. Now, regular web API gives data directly to an end user, like after sorting it into an index. We didn't like that because it didn't have this ability to publish IPFS, so we wanted to give these chunks to the end user, and that's kind of what Shifra Export does. But the user had to have built the entire index themselves, and we didn't have any way to get the index to the user except through this, them running our software, which no one did. So we said, okay, we know we want to move the end user over a bit. We know we like IPFS, and we want to just store these chunks into IPFS, store a manifest into a smart contract, so we just periodically write the list of IPFS hashes, and that can be hashed as well. And then we create what we call the unchained index. And that whole thing is called the publisher. And then this problem of how do people get the data is with something called Shifra init, and they run that, and it basically reads the smart contract, gets all the hashes, and downloads from IPFS. And they can trust it if they want to, they don't have to. They can, if they want to, run the software, run Scraper themselves, they'll get exactly the same hash, and they can believe it's true. And then you can do Shifra Expert and do all kinds of stuff like serving locally and running applications. But this, at the time, was 50 gigabytes. It's now, I think it's either 165 or 650 gigabytes. I'm not sure. I think it's 100. I don't think it's 600. Anyway, it's big. So there's this absolutely fantastic data structure called a Bloom filter, where you can take a list of data and you can create little tick marks on a bit stream. Does anybody know what a bit stream is? Who's got a bit stream here? You can tick little bits of this data and you get this tiny little thing that says, you can query this thing for an address, and it says, with 100% certainty, it's not in that bigger piece of data, and with some probability of false positive, it is. So what we did is we took I'm going to say 650 gigabyte index, and we were able to squeeze it to 6 gigabytes with a Bloom filter. So now Shifra init downloads 6 gigabytes, which is every time you download an application, you're downloading more than that. Probably Microsoft applications are 100 gigabytes and more. So this Bloom filter is amazing, and it's immutable because it's a derived piece of data, and we publish the specification of how we build it, so anyone who wants to can reproduce it. And then we include that in the manifest, and now the user downloads 1 gigabyte. And when they run Shifra Expert on their own address, the Bloom filters tell them that instead of 1,500 chunks of data, they only need 6 chunks of data, and they download those chunks. And then we have them pin that data down on IPFS. And now what we created is a shared burden. We put the burden on the user to carry his own data. But these chunks, as I said, have 2 million records in them. So they might only want 7 or 10 or 20 records, but they carry 2 million records. And we did that because we want them to share more than they take. And this is the nature of a peer-to-peer network. You have to share more than you take, and that's, my hope was that that would be so obvious to people that they would say, of course I want to do it that way. Because it solves all of these problems that we have with APIs and privacy, and you know, you're shoving the responsibility of the data down to where it belongs, which is the people. So if we want to participate in the system, we all have to pay. And I'm saying, you don't have to pay by buying coins or doing or staking or something like that, that's fine. You should pay by giving some part of your hard drive up and sharing the burden of the data. Because otherwise it gets carried by Amazon. That's the only alternative. It's either all of us or one of us, because Amazon wins the game, or Google wins the game and get two people with all the data. It's such a bad idea. So, does anybody have any questions, comments, or anything at all? You with me?
Yep.
Yeah, I got a question for you, which was, you mentioned that the burden will be shared amongst various users. So obviously, there's gonna be some redundancy built into that system, right? What's to keep somebody from, like Amazon, from collecting all the data anyway?
Privacy-wise?
Yeah.
Nothing whatsoever, absolutely nothing.
They can set up a million servers like that.
Absolutely, they can, it's open data, everybody has access, and that's
Really
why,
want it, they can still get it.
that's why I feel like your only hope, if you truly want to be private, is to never reveal anything about yourself, ever.
Okay.
Stay behind, you know, stay local on your machine. Never expose yourself. And if you're running a node software yourself here, let's say the whole world goes to, you know, blockchain as the mechanism that we share data. If I was running a node myself here, I can create a brand new address, use some kind of, what do they call it, mixer out here, mix data, get money into this address that's never been seen before. And now I can transact all I want because I'm only transacting against the chain. And I know I'm not revealing my IP address attached to my address. Except for certain things, like maybe I want to join a DAO, and then the DAO has a rule that says they have to expose the addresses, and I think that's good, right? Now I have to segregate two different kinds of addresses. One is my public space address, and one is my private space address. And I have to know that my public space address is known by all the planet. And I have to be careful what I do over there if I don't want to get, whatever. If I want to be private, then I have to keep my private address private. And I think anybody that's telling you that there's some kind of solution where, you know, I can't even imagine what the solution is where it's partially public, where it's somewhat private. As soon as it's public, it's purely public. And I think everybody will have two different sets of addresses. And it'll be built into the software, so you won't have to, you'll know this is called my private address. It's like incognito or something like that. One of the tools we built is called Create Local App. And this is saying that, so we built all this software, extremely complicated and totally poorly done, not documented at all, just a total nightmare. But it takes advantage of this index, and it takes advantage of the speed of a local machine. And we try to show that you can build some pretty interesting things locally on a machine that's not connected to the internet. Okay, so this is, I'm just gonna scan across the top here. This is all the data that you can get from a blockchain. And it's for my particular address, and it's really, really fast. This has, it's much lower here, but there's 2,300 transactions on this address. Now, if you wanted to go page by page on a web page, you're hitting next. You can't do this. And for every one of these transactions, we looked at, this is transactions that transfer value of a token. We call this a statement, which is basically a profit and loss statement. It just shows beginning balance, incoming, outgoing, end balance, and a better balance. We call that a reconciliation. That's what this true is here. So this is, I had that money, I sent it to that guy, I used to have that much, and then I spent that much, and now I have that much. And this is probably transferred to myself or something like that. So this is what you get when you have speed, and when you have a perfect index, is you get the ability to see 40 different types of data. These are all the approvals that are still open on this account. And I'm working on putting a little revoke thing there.
Yes.
The only possible way for me to now revoke my approvals, I can't even know what my approvals are because Etherscan doesn't show them to me. I have to go to revoke.cash, which is a VC funded thing. And if you think they're not watching what we're doing, you're crazy. And this just works because we can see every single thing that happens. This is my personal address. Let's say it's my DAO. Let's say it's the DAO, right? Or a DAO that I belong to. I can see every dollar that's spent on every DAO. I can see who it went to, and I can trace down through that person's expenditure, see if they're spending it on porn. Right? And now I become a willing and active member of this DAO because I know that I can watch the money, and I know there's not a special cabal of people who are spending money ridiculously. And now DAOs become, I think, the best organizations we've ever created because there's people like Kirk who are going to watch every dollar just because that's his anal retention nature, and mine as well. I'm just going to watch because I want to see it. You can't do this with a web server because they're serving 10,000 people off the same powered machine, and they're not going to give you this much information because they have no incentive to do that. Their incentive is to give you the littlest amount, put as many people on the machine as they can. And this to me is this depth and this clarity of what's happening on an address is why people will use these things in the future. Because that's the promise of 18 decimal place perfect accuracy on chain. I could run a business. Let's say I had my business had all smart contracts. Every department has smart contracts. We could feed up, and I could get instantaneous every 18 seconds. I could get a profit and loss on my business because every expenditure goes through my business. Privacy is an issue there as well, obviously, but so this to me, speed is the really important. It's one of the really important things, and it happens because I'm by myself on my own machine. I can't understand how to. I think the only way we ever get to this place is when you buy a computer, it has a chain running in the operating system, and then you naturally are behind the node software. You're naturally using your own RPC, because otherwise, no one is ever going to install this and run this software. So this is called Explorer. And basically what I did here is just every possible, this is called a monitor. There's two things that happen with this thing that constantly runs. One is indexing the chain for addresses, and the other is watching particular addresses that you can extract. Remember I said you only extract the smallest amount of data for the index? But we also have this monitor process that extracts the full detail of any address that we tell it to extract. So now you have the best of both worlds. You have the smallest possible database, but it's always available and it's all cached locally on the machine. So it's super fast. And you can do all kinds of stuff. You can do charting, and I'm just getting started on this. So this is my address again, and I can't figure out how to show the balance. It's broken. But this is what I'm saying. This is every token that I've ever interacted with. And you can see, these are obviously airdrops. They basically just put tokens in my address. I never even knew they were here, right?
And they're all up only.
Just got it. Well, no, see, what I would say is, if I can see Uniswap, all the smart contracts for all of these pairs, so I would look for a pair of this address against Ether or US dollars or something, and I would find no entry, probably.
Right.
And then I would make this 0, right? Its value would be 0. So if I was showing US dollars, all these would be 0 value.
For sure.
Yeah. But that's another thing, it's derived data. Derived data is in Uniswap, like, because the pairs are trading actively every 12 seconds. So you're getting a price feed every 12 seconds. But I don't have to have the entirety of all of Uniswap to get the prices, right? I know I only want it for transaction 7, block 400 for this address, right? So I can extract the full price history for my addresses, and I don't have to have an API that feeds me prices. It's kind of an upside down way of looking at the thing, because you're kind of restricted by what you can do because you're on a laptop. I just wanted to show you another thing. So this is, if you look at this column called appearances here, every one of them is 2 million. So this is what I was saying before, where we keep accumulating these appearances until we get to 2 million or just above, because we want to finish the block. And that number stays pretty flat all the way through the whole history. And we did it that way because we wanted to, I don't know if this is true or not, but I feel like, if you have equal sized data and any arbitrary person searches, they're just as likely to get one block over another. Does that sound right? Or not particularly?
I can't tell you for sure.
That was my intuition anyway. So I just picked this number, 2 million, but I wanted all these chunks to be about the same size, so you'd hit on them as likely as any other block. And I don't have a chart that shows that, but that would show that. This also is basically a wallet, so we can, interact with the chain if we wanted to. I'm very shy about doing this because I don't want to lose all my money, basically. Then we get to this thing, which is, I showed this to some people before. So this is generative art, basically. And we take your address and we chop it. You chop it into little pieces, and then you pick a record out of 20 different databases: color, adjective, adverb, noun, literary style, artistic style, all this different shit, emotion, and you let it go, and you just send it over to the AI, and the AI comes back with, I say, give me a story about this particular type of data, and it comes back with this story, and then I say, draw an image of the thing. I wanted to make this into videos, actually. These images are freaking crazy. So I said I was going to become an artist. So I buy these sketchbooks, and I try to sketch these things. So this is going to be my art. So that application I just showed you is like a Swiss Army knife. It basically has every single piece of data, any type that you can get from the chain. But we have this ability to turn off all these different parts of the application. So, so this one I wanted to just focus on approvals. I want to make a tiny little application that's just approvals to say focus. is just approvals, and it only shows the monitors and the open approvals and all of the assets that you have. And this is called Dolly Dresses application. And this one only has Dolly Dresses and names. So basically you pick and choose all these little parts, and you can, when you run that application called Create Local App, you can tell it which parts you want to include. And it gets you started. And then you have, I'm gonna add one example called DAO Manager, which lets you find DAOs and participate in DAOs. You can do literally anything, any data. You have every single bit of data here. And if you use this software or something similar to it, as a naturally occurring outcome without you doing a single thing, you share the index with all the users in the world, because you have to download it or build it yourself, and it's pinned to IPFS. Everybody knows where it is. So you get a system that over time, if we had 100 million people using a system like this, IPFS would download instantaneously 6 gigabytes of Bloom data. Currently it takes forever on IPFS because I'm the only producer, right? But if there was 100 million people producing, because we built a system on purpose that purposefully distributed the data, we would get what we want, which is permissionless access to excellent applications that are just as fast as they can be and give us 18 decimal place accurate off-chain. That's it. That's what I've been doing for 8 years.